Hi, welcome to TechnipFMC Tech Talk, where experts from around the company take you on an immersive journey into the various industry topics, from equipment to processes, covering the common trends and what's next. I'm Chris Egan, Technical Manager for our front-end and system engineering team based in Houston. Welcome to our third and final Tech Talk around setting standards. In the previous two Tech Talk sessions on setting standards, my colleagues discussed how our industry has evolved over time and the need for standards to ensure safe and reliable production of oil and gas. They then discussed how these standards are applied and used. They also touched on the role of the equipment suppliers, service companies, and operators collaborating to develop and maintain these standards as our industry evolves. In this session, we will look at putting standards into practice and applying a system approach. There are standards that govern each piece of equipment in a subsea field, from the wellhead and tree to the manifolds and tie-in systems, all the way through the flow lines and risers to the host. They also address the supporting electric and hydraulic controls and the equipment required to operate the subsea field, along with the installation and intervention systems. Each subsystem or piece of equipment is designed to its own standards. In between, there are breaks in the specifications, and it is often up to the system integrator or operator to determine the best way to manage these interfaces so that there are no gaps or conflicting requirements. This is where the contractor, as a system integrator, can ensure a seamless and efficient method of applying the standards appropriately when designing the system and specifying the system requirements. In the prior talks, you saw a graphic like this showing the relevant specification for each major item in the subsea field. The example shown here illustrates the various API standards. Understanding where and how to apply the spec break between these standards is important to prevent conflicts or gaps. For instance, you see subsea umbilicals and subsea controls have a mating interface, but they use a different approach on how they define the size of tubing that they use. Control tubing is defined by the outer diameter, but umbilical tubing is defined by the inner diameter. Understanding this interface is critical so that when a piece of tubing is procured, that they match appropriately. So understanding how the material is defined is super critical to make sure the interface is intact. Similarly, there's different design codes and standards used for the flow lines, but different codes are used for the structures that they're mated to. But you would like to use the same piece of pipe so that for compatibility and also for delivery and cost concerns. But understanding how to use the right approach and the right standard to define the appropriate size pipe is very important. Another example is the standards used for cathodic protection. There are many standards on the market, but understanding how to apply those standards is very important. The CP system must have anodes on each piece of equipment, but for instance, you might choose not to apply anodes to the flow line or to a jumper. But the manufacturer of the tree or manifold adjacent to it would need to understand that they need to provide adequate protection by applying an appropriate amount of anodes. So understanding the system design for cathodic protection is very important, and the code does not define that. It only defines that you need to have cathodic protection. A system integrator with in-depth experience in system design and manufacture can ensure an efficient application of the standards to prevent conflicts, gaps, or overspecification. In addition to the general industry standards intended for global use, there are many regionally focused standards and regulations which can specify special requirements to suit that region's needs. For example, over-trawlable or fishy-friendly structures are required for the North Sea to prevent fishing nets from getting caught on the equipment. And equipment destined for warmer, shallower waters like offshore Australia need to prevent marine growth that could interfere with the equipment operation. So you might have to use protective covers or special coatings. It is vital for the operator and the equipment supplier and the contractor to fully understand the regional requirements and invoke the appropriate regional standards when necessary. It's also important to note that the industry standards do not define the functional requirements for each piece of equipment. Things like bore size, pressure, temperature rating. This is left to the operator or the system integrator, whomever is responsible for the system design to define. There's a significant amount of feed work, front-end and engineering design work, required to establish the system design and functional requirements, which would be compiled into a basis for design document. It is critical that that BFD dictates the industry standards, the regional standards, regulations, as well as the functional requirements for the project. Another key point to note is that the industry standards do not convey the technical details of the equipment. These details are typically proprietary to the equipment supplier and not considered industry standard features. So understanding that the interfaces between this equipment is critical. For instance, an outlet hub on a tree must match the mating jumper connector for the well jumper that it's going to be mated to. These designs are proprietary, so they must come from the same supplier. This can often influence the contracting strategy to ensure these interfaces are compatible. Using an integrated execution approach can eliminate some of the potential interfaces and interface concerns, both in the physical means of compatibility, but also in terms of application of a common set of industry standards without gaps, conflicts, or even overspecification, which can result in an uncompetitive solution. As a hardware supplier and equipment integrator, we value standardization and the opportunity to make the same set of equipment suit each operator's needs, which is a challenge. This is sometimes more challenging when the project requirements greatly exceed what is considered the industry standard. Use of industry standard equipment provides an opportunity for the supplier and the operator to reduce cost and lead time and leverage supply chains and stocking programs for long lead items. It also provides an opportunity for interchangeability across projects, which is key to make things economic. Some standards have been initiated by the operators to attempt to harmonize and align on requirements across the operators, with the hope that this will enable more standardized solutions from the equipment suppliers. With the recent industry downturns and renewed focus on cost and time to first oil, this area is getting a lot of focus and attention, and we look forward to working towards mutually beneficial solutions in the future. As we move forward towards our industry's goals towards renewables and green energy ambitions, consider the new technology that will need to be developed and the standards that will be required to make the system work together and operate safely and reliably. Equipment suppliers, service companies, system integrators, along with operators, need to continue to collaborate and refine these standards as our industry evolves and new technologies are developed and deployed. There are some instances where existing standards can be applied and repurposed, but this may not always be the case. For instance, our current standards are based on the traditional electro-hydraulic controlled systems, which have been used for more than 20 years. But what happens when we switch to fully electric operated systems? Do the standards need to be updated to address this technology leap? Are we holding ourselves back? Other examples include using existing subsea system designs as a means for carbon capture, usage, or storage. Does this result in a different material selection philosophy? Are the materials even compatible? And are the current equipment requirements overspecified for non-hydrocarbon service? Are there opportunities to develop specific standards that would result in a lower cost solution to enable this approach economically and technically? Another example would be to place an offshore wind turbine, as shown behind me, on an existing TLP or offshore structure. The loading may be different and require a different design and analysis approach to ensure a feasibility and safe operation. I hope you've enjoyed our series on setting the standards. Give this video a thumbs up and don't forget to sign up for our future Tech Talk communications.